Welcome and hello. This is a video exercise in HEC RAS, and in this exercise, I'm going to be exploring different pump rules. So I'll be running some simulations with pump rules and then looking at some results specifically in DSS view, some DSS results. All right, so let's get started here. I'm going to click on File, New Project, navigate to the project directory, and then go ahead and type in a title for the project and then click OK. Okay. I have the geometric data editor open down here, but if you don't, go edit geometric data. Now what I'm going to do is instead of sketching out a river reach, I'm just going to be sketching out some storage areas and then pumps between those storage areas. And then I'll be able to set the rules up for the pumps and run the simulations and view the results after that. All right, so I'm going to click on storage area, and then I'm just going to start sketching out a storage area right here. Double click. I'm going to call this Lake 1. Okay. So what I'm going to do is we're going to have 4 different lakes, 1, 2, 3, and 4, and then 4 pumps between them. So for Lake 2, I'll click storage area, and then I'll start sketching, start with a single left click, and then just continue with single left clicks at each vertex point of the lake, and then a double click. I'll call this Lake 2. And then there's Lake 4. So I've got the 4 lakes sketched. Now what I want to do is add some pump stations. So I'm going to click on the pump station right here and then just click between lakes 1 and 2. I'm going to name this pump 1, 2 because it's going to be pumping from Lake 1 to Lake 2. Okay. And then again, I'll do the same thing here. This is going to be called pump 2, 3. And then the 4th pump was going to be called pump 4-1. So I got my lakes and my pumps all set up. Let's go ahead and define the geometry for each of the lakes, or storage areas they're called. So this is for lake 1, 2, 3, and 4. And then what I'm going to do here, let me just go back to lake 1 to start. I'm going to highlight the elevation volume table here. And what I did before, just off camera, was I copied the values that I want pasted in here onto my clipboard. So Control V, and then let me just scroll up, and boom, here is the data. So the bottom of the lake is at elevation 120. The top is at 140, and you can see how the volume increases from 0 acre feet up to 400 acre feet for this lake 1. I can also click on this plot the volume versus elevation curve so we can see that right here. And then let's go ahead and use that exact same data for all 4 lakes. So I'm going to advance down to Lake 2, highlight, paste, and then confirm. Looks good. Okay, so I did that for all 4 lakes. They all have the same size and geometry. Even though they may look different on the map, what's important is the geometric data that's saved in the geometric file. Speaking of which, I'm going to go File, Save Geometry Data. Now, what I'm going to do here is create one geometric file that has no pumping and then a second one that does. So this is going to say no pumping and then OK. Next, I'm going to define the pump. So I'm going to go Pump, Edit Pump Station. Now I have my 3 tabs here for the connection, the pump group data, and then the advanced controls. For pump connection data, what I want to do here is just tell HEC RAS that pump 1, 2 pumps from lake 1 to lake 2. So storage area from lake 1, storage area to lake 2. As you can see here, there's other options for pumping in and out of river stations, pipe nodes, or pumping out of the system. All right, so I'm going to continue that process. Oops, did I not save pump lake 2 here? Lake 2, and okay. Oh, I want to cancel this. That was an accident. What I want to do is continue that process, but when I click OK, you can see the lines are now drawn with a little arrow, which might be a little too hard to see, but I could zoom in if I wanted to. Anyway, pump 1 pumps from lake 1 to lake 2. I'm going to continue that process for the other 3 pumps. And then the pump outlet for pump 401 is actually going to be lake 1. So click OK. Click OK. We have the diagram updated right there. That looks good. Let's go back to the pumps and define the pump curve here. So edit pump. The next tab over is the pump group data. I'm going to leave the startup and shutdown time at 0. I'm going to initially set the value here to 9999 and 000, or just 10 is fine, for water surface elevation on and off, which is far beyond the range of the water surface in all of the lakes. So that means we're not going to have any pumping, and that's what I want for this initial geometry file. Okay, next I need to come over here and specify the pump curve. So I think I have that data saved on my Excel file here. So I'm going to come back to HEC RAS, highlight the cells, Control V to paste, and then boom, there's the pump curve. I can also take a look at that pump curve by clicking this Plot Pump Efficiency Curves button. All right, so I'm just going to do that for all 4 pumps. Let me advance to the next pump here. This is pump 2-3, and paste, pump 3-4, paste, and then pump 4-1, and paste. All right. Later in this exercise, we'll visit the advanced control rules, but not right now. All right, so I'm going to click OK. I want to make sure to save that geometric data file. Boom. Now we're ready to create a flow file. This is going to be an unsteady state simulation, and it's going to be for 3 days on an hourly time step. So edit, unsteady flow data. For boundary conditions, there's nothing really to do here because there's no rivers or reaches. This is perhaps not what HEC RAS was originally intended to do, but this is how I'm using it for this exercise. Initial conditions, though, we do have to specify the initial elevation of our 4 lakes. Now, what I want to do is set up the lakes so that they are initialized at half volume. If I come back to the lakes itself, let me go ahead and take a look at this volume curve. We have elevation from 120. The maximum volume is 400 acre feet. Half of that is 200, which acre feet, and that corresponds to an elevation of 134 feet. So let me go back to the initial conditions and just type in 134 for all 4 of the lakes. I'll just paste that in. All right, file, save unsteady flow data, lakes half full. And that'll be the starting conditions. Okay. Okay, so we're done with that data. I'm going to close this dialog box. Now go to run unsteady flow analysis. And then for this plan, which is going to have the no pumping geometry file, lakes half full unsteady flow file, I need to give the plan a name. I'm just going to call it no pumping. So file, save plan, no pumping, and okay, no pumping. Now I mentioned earlier that I want it to be a 3-day simulation. So I'm just going to go from January 1st, 2020 at the beginning of the day until January 4th. So through January 3rd. And then that's also going to be at 100 hours. The computational settings down here are fine. And then I also need to click on these checkboxes right here. So let's go ahead and run this and just see what happens. Okay, I've got a couple messages here. Okay, so I forgot to input the data for the pumps off camera. 1 second. And say 999 and 0. Okay, let's try that compute once again. All right, looks like we're good. Okay, there's really nothing to look at. What we're going to see here in the view, I mean, there's no channels, there's no rivers, there's no water surface elevations except for the lakes themselves. So if I click on cross section, I'm not going to see anything. If I click on view, water surface profile, it's not going to be anything. In fact, using the view menu offers very limited results. The stage and flow hydrograph will have something. And with no pumping, it's just going to be a constant 134 water surface elevation for the entire 3-day simulation. What we're looking at here is Lake 1, but I can change that to, Lake 2. That's going to be the same, Lake 3, and so on. Let's go ahead and add some pumping. And then when we do, we can look at the results in HEC RAS, but what I also want to do is look at some results in HEC DSS view. Directly from the DSS paths that are written during the compute routine. All right, so let's get started with some rules. I'm going to close this dialog box. Let's go from pump 1-2, edit pump station, advanced control rules here, add rule, always on, okay. And what I'm going to say is that it's just a constant 20 CFS. And that's going to pump for 3 days straight from Lake 1 to Lake 2. I'm going to save this geometry data file as pumping now. And okay. And then let's go ahead and run that simulation and just take a look at what happens, what the flows look like, and what the water surface elevation looks like. Save plan. It's going to be called pumping. Okay. And pumping and run. Okay. So that looks good. Close. If we want to look at results, again, we'll go up to view. The only thing, like I said, that really makes sense to look at here is the stage and flow hydrograph. This is pump 1-2. And we have a constant 20 CFS pumping. And we see the water surface elevation increase in the tailwater and decrease in the headwater. All right, if we want to go ahead and take a look at these results in DSS view, let me go ahead and fire up that program. All right, so I have that open. I need to open up the DSS file. So let me navigate there. All right, this is my project directory. So I'm going to click on exercise15.dss. Your DSS file will be something like that. Click OK. Now what I have in part F is the plan, whether it's pumping or no pumping. So I'm going to just filter so that it's only showing me results from pumping. And now one thing I could look at, I could scroll down here and look at the stage for all 4 lakes. So I'm holding down Control and single left clicking to select, then click the graph button. And now what we see is Lake 1 is decreasing, Lake 2 is increasing, and then Lakes 3 and 4 are just both staying steady at that initial water surface elevation of 134 feet. We could also take a look at the plot of what we saw over in HEC-RAS. If we wanted to isolate Lake 1 and 2 stage, but then also include the flow rate through pump 1, 2, we could do that. And now what we see here is the constant 20 CFS flow pump in the top plot. And then the bottom plot is the water surface elevation. Here is Lake 1 and here is Lake 2. All right, so now that we got a general feel of how this exercise is going to continue, let's go ahead and add some rule for pump 2, 3. So I'll click on Advanced Control Rule, Add New Rule. I'm going to click on Apply Based on Hour and Day, and then click OK. The maximum here I'm going to say is 100. The minimum is going to be 30. And then what I want to do is pump for just the afternoon time period. So during the morning, nothing will happen. So I'll say January 1 to January 1. It'll start at 12 and then it'll end at 24. And then what I want to do is repeat this for all 3 days because this is just going to be 12 hours during the afternoon of the first day. So I could copy rule. And then here's the first rule. Here's the new one that I just created. I'm going to change this Jan 1 to a Jan 2. And then copy once again and change Jan 2 to a Jan 3. All right. So I'm going to click OK. I'm going to save this pumping geometry file. And then let's go ahead and run the compute. Okay, so that completed. I'll click close. Now I'm just not even going to deal with this data anymore. I'm going to go straight to DSS view. View, refresh catalog, part F, pumping filter is still applied. We're up to 112 different paths. 28 are shown. I'm going to scroll down and let's take a look at the stage once again for the 4 lakes. And then we can focus in on just what we see at pump 2, 3. All right, so I got those highlighted. And then here is the diagram. As before, Lake 1 continues to decrease for the entire duration of the simulation. And then Lake 3, as you notice, is constant water surface elevation in the morning, and then it increases during the afternoon because pumping through pump 2, 3 turns on during the afternoon. Morning, no flow, afternoon, flow. All right, so what we're seeing here in Lake 2 is a little bit more complicated because it's receiving pumping at 20 CFS from pump 1, or from Lake 1, which is pump 1, 2, in the morning and the evening. However, the flow rate leaving Lake 2 is a little bit higher, which is why we're seeing a decrease here. Let me go ahead and focus the results on just that pump 2, 3. So here's the total flow, and then I'll get the stage for Lake 2 and Lake 3, and then look at the results. Okay, as we expected, we have pumping only during the afternoon. So this is the flow rate through pump 2, 3. And then, as we saw earlier, we have the water surface elevation in Lake 3 and the water surface elevation in Lake 2. All right, what I want to do now is refill Lake 1 so it doesn't get so low. And I'm going to do that by adding a control to pump 4.1, which is going to pump water from Lake 4 into Lake 1. All right, I'm going to click on Advanced Control Rules, Add New Rule. This is going to say based on target water surface elevation. And then for my trigger right here, I'm going to set it using Lake 1. Yes, that's it. That'll be the trigger. And I'm going to say the minimum is 133 feet. So Lake 1, all the lakes start at 134 feet. However, Lake 1 does nonstop pumping into Lake 2 at 20 CFS. So I want Lake 4 to refill Lake 1 on an as-needed basis. I'm going to set the trigger max water surface elevation to 135 here. And then for flow, I'm going to say 100 and I'm going to say 40 CFS for a minimum. Okay, so let's go ahead and click OK and see how that works. File, save geometry, and then let's go ahead and run the simulation. Okay, it does show an error of 9.4 acre-feet in volume, so I may need to change something, but I think the results still wrote, so let's go ahead and see what the results look like. Back to DSS view, I'm going to view, refresh the catalog, and one thing I'm going to do first is just look at the stage in all 4 lakes to start with, and then plot. Now this actually looks correct. This is what I was expecting to see. Lake 1 starts to lose water, then the pump turns on from pump 4.1 turns on to maintain that water surface elevation at 133. However, to do so, we see Lake 4 starts to drain at probably 20 CFS because that is what pump 1.2 is pumping at. And then the water surface elevations in lakes 2 and 3, those are the same. So let's go ahead and focus in on pump 4.1 now. Pump 4.1, total flow. And then let's look at the stage of Lake 4 and also Lake 1 stage. There we go. All right, so this looks good. What we see now is just what we saw before. On the bottom, we see the water surface elevation in the 2 lakes. Lake 1 goes down to 133 and holds constant. Lake 4 actually stays at 134 until Lake 3 is at 133, and then it pumps out at the same rate as pump 1.2. Now up at top, since we set the 40 CFS as the minimum flow, we're seeing a lot of turning on and turning off throughout the day, which starts in the looks like the afternoon of the first day. But if I change that pumping minimum to something higher, we'd see even more on-off operation, or if I changed it to something lower, we would see less on-off operation. This on-off operation probably isn't very good, but let's change that minimum CFS to something like 25, in which case we would have less turning on and turning off. So back to pump station 4, and then advanced controls. I'm going to change 40 down to 25. Okay, as long as it's at least 20 CFS, it should be able to maintain Lake 1 at 133 feet of elevation. All right, so let's go ahead and run that. Okay, it looks like we're below tolerance now. We don't have that error. In close. All right, back to DSS, view, and then view, refresh catalog. Let's focus in on pump 4.1 again. So let's also get the stage of Lake 4 and the stage of Lake 1. And here's the plot. Okay, it's on a lot more, but it looks like the frequency is just as often. So I misspoke there. If I changed it down to 20, it would just be a constant 20, and that's probably what we should be doing. Okay, one more pump we need to add some controls for. So before we do, let me just take another look at the stage of all 4 lakes. And what we see is Lake 3 is the highest at the end of the simulation. Lake 4 is the lowest stage, and that's because pump 3.4 is the only one that's not operating. Maybe what we could do is pump 3.4 so that towards the end of the simulation, both water surface elevations are closer to 134. Okay, so I'm going to close this. Let's go back to HEC-RAS. Now I'm going to click on pump 3.4, edit pump data. And then what I'm going to do here, I could use some advanced control rules, but what I'm going to do instead is just modify the original values here, the basic controls for water surface elevation on and off. And what I'm going to do is say that the water surface elevation in Lake 4 cannot go below elevation of 132. So what I'm going to do is say it turns on at 132, and then it turns off at, I don't know, about 134. And one other thing I need to do is change the trigger or the monitoring reference it's called. And by default, it's going to be Lake 3 or whatever the pump inlet is. But what I want to do is change it to Lake 4, which is right there. And then I'll click OK right there. I think this should work. So let me save the geometry file and then save the project and run the simulation. Okay, so it looks like we do have a little bit of volume error. I'll look at that a little bit later, but close, and then let's go ahead and just look at the results to see if anything changed. View, refresh catalog. Now I'm going to open up the stage in all 4 lakes or storage areas once again. Awesome. Yeah, so this is what I was expecting to see. We now see towards the end of the simulation that the cyan line here, which is the stage of Lake 3, sort of mirrors the stage of Lake 4 in yellow. And that's because we know that pump 3.4 is running basically from, what was this, probably about 6 a.m. of January 3rd until early afternoon. So let's go ahead and take a look at that pump 3 data. Sorry, I'm calling it pump 3. I meant pump 3-4, which is right here. Here's the total flow. And then for reference, I'll go ahead and also include the stage of lakes 3 and 4. All right, as expected. Wow, so it's pumping at 100 CFS, and that's probably because the pump curve, that's the maximum value there. So the trigger is when Lake 4 elevation reaches 132, it pumps and pumps and pumps until the elevation at Lake 4 is 134. So anyway, lots of pumping and lakes and DSS view results in this exercise to give you a little bit more exposure and experience with these features within HEC-RAS.